Hey guys, welcome back. Houston Math Prep here. In this video, we're going to take a look at composition of functions. So a composition of functions occurs when one function is placed inside of another function to create an all-new function. So we say that our new function is composed of one function inside of the other. So notationally, we tend to see this as f of g of x. So g of x is going to be your input into f of x. I do want to point out for you that there are a couple different ways that you might see this notation. One of them is with an open circle in between. So sometimes you might see f of g of x. All right, and another is kind of the same, only sometimes they'll use brackets. You might see something like f of g of x. And all of those mean the same thing. G of x becomes the input to f of x. So let's take a look at how that is done. So here are two given functions. F of x equals 2x squared minus 1, and g of x equals x plus 3. So if we're going to create the function f of g of x is going to be our input into the function f. So we can think that this is f of, go ahead and place your g in there, x plus 3. Now we know from function notation that when we see f of whatever is here, that is what we replace x with in our function f. So this will be 2 times, I'm replacing x with x plus 3, it's squared in my definition, and then minus 1. So here's my new function, my composition, 2 times x plus 3 squared minus 1. So we can see all of g of x is inside f of x. Now from there, it is pretty typical that we want to simplify as much as possible. So here, that would look like going ahead and expanding my x plus 3 squared. So that would be 2 times x plus 3 times x plus 3. Doing that multiplication, so that would be 2 times x squared plus 3x plus 3x plus 9 minus 1, and then combining like terms and distributing my 2. So that would be 2x squared plus 3x makes 6x. 2 times 6x would give me 12x, plus 2 times 9 would be 18, minus 1. And so my final result would be 2x squared plus 12x plus 17. So my new function, created by composing g into f, is 2x squared plus 12x plus 17. All right, now we want to compare that with g of f of x. Notice that this time, f of x is our input, and it's going to be placed into g of x. So we can think of that as g of, well, here, f of x is 2x squared minus 1. So function notation here tells me into g, replace all my x's with 2x squared minus 1. So that will be 2x squared minus 1 in place of x plus 3. Here, the only simplification that needs to be done is to combine my like terms. So this is 2x squared plus 2. So g of f of x is 2x squared plus 2. Something really important here to notice is that these are not the same. So that's something we want to note, that in general, f of g of x is not usually equal to g of f of x. So order of composition does matter. Notice I did say here in general, there are some functions for which f of g of x does equal g of f of x, but we can't count on that being the case. All right, here are some new functions. Let's give this one a try. So g of x here is 2x minus 3, and h of x equals 4 plus x squared. Let's find first g of h of x, and then evaluate g of h of 2. So here, my input is h of x. So I'm going to have g of 4 plus x squared. So that tells me, function notation-wise, to take 4 plus x squared and replace it into g everywhere there is an x. So that would be 2 times 4 plus x squared minus 3. I'm going to go ahead now and simplify that by distributing my 2. 2 times 4 makes 8 plus 2x squared minus 3. And then combining my like terms, I get 2x squared plus 5. So my new function, g of h of x, equals 2x squared plus 5. So now that we've created this new function using function composition, we can also evaluate that function at differing values of x. So here, g of h of 2 tells me to, in my new function that I created, replace my inputs with 2. So in this case, replace my inputs of x with 2. So that would be 2 times 2 squared plus 5. Well, that's 2 times 4 plus 5, or 8 plus 5, or 13. So in my function g of h of x, when h is 2, y is 13. All right, let's check out one more look. Here, notice we're going to first create the composition backwards, h of g this time. But notice I'm not first finding h of g of x. I'm going straight to evaluating with numbers. Now, there's two main ways that you can do this. You can do these exactly like we did the previous, by first finding h of g of x, and then replacing your input of x with -1 and then 0. The other way that you can do this, if you don't want to do this first, is you can simply evaluate from the inside out. So I can first just find g of -1 and just leave that inside h. So finding g of -1 tells me into g of x, replace my input with -1. So that would be 2 times -1 minus 3. So this would be h of 2 times -1 is -2, minus 3 makes -5. So now I've found that g of -1 is -5. So now I can go ahead and continue by finding h of -5. Well, h of -5 tells me to replace the inputs in my h function with -5. So that will be 4 plus -5 squared, or 4 plus 25, or 29. So by going from the inside out, I found that h of g of -1 is 29. All right, let's see that process one more time, this time with different inputs. So h of g of 0. Again, if you don't already have h of g of x, start by evaluating g of 0, which says into the g function, replace your input of x with 0. So replacing my input of x with 0, this will be h of 2 times 0 minus 3. So that will be h of 2 times 0 is 0 minus 3 makes this h of negative 3. So now, finishing off, I'm going to into my h function, take my next step, and replace my input of x with the input of negative 3. So that will be 4 plus negative 3 squared, or 4 plus 9 gives me 13. So my y value for h of g of 0 is 13. All right, guys, that does it for this video on composition of functions. We'll catch you in a future one.